Gamma ray bursts, these cosmic ray guns, are the most powerful, the most deadly weapon that the universe has come up with.
The jets of a gamma ray burst actually don't last very long. They go off in really just a couple of minutes. But in that time, the energy released is equivalent to 100 trillion nuclear weapons going off every second for 100 billion years.
Scientists capture universe's strongest explosions that can destroy our planet. When one of the brightest explosions in space reached Earth space, ground-based telescopes witnessed it. The burst could be among the most powerful ever observed by telescopes. According to NASA, gamma-ray bursts, GRBs, are the most powerful type of explosion in the universe.
Key insight here is that we're not talking about something that's exploding like a sphere and spreading its energy out in all directions. A gamma-ray burst is beamed, so it's taking all of its energy but pointing it right at us and firing it directly towards us. That's why it's so powerful.
Scientists named it GRB 221009A, and telescopes around the world are still monitoring its aftermath. Brendan O'Connor, a doctoral student at the University of Maryland and George Washington University in Washington, D.C., said the exceptionally long GRB 221009A is the brightest GRB ever recorded, and its afterglow is smashing all records at all wavelengths. What and where did this massive explosion come from? Gamma-ray bursts are giant explosions in distant galaxies that send out swarms of powerfully energetic gamma rays. Stars, supernovae and other objects in space radiate away their energy in various forms of light, including radio wave, microwaves, infrared waves, visible waves, ultraviolet, X-rays, and gamma rays that are known to us. As a result, they are some of the most powerful events in the universe, and the explosions that create them are quite bright in visible light, too. This particular explosion, which scientists named GRB 221009A, which sounds more like a license plate, believed to be the long, bright pulse that was produced when a massive star in the Sagitta constellation, approximately 2.4 billion light-years away, collapsed into a supernova explosion and became a black hole. The star's mass was most likely many times that of our sun. Gamma rays and X-rays rippled through the solar system, activating detectors on NASA's Fermi Gamma Ray Space Telescope, the Neil Gehrels Swift Observatory, and the WIND spacecraft, as well as ground-based telescopes such as Chile's Gemini South Telescope. Brendan O'Connor added in his statement, "Because this burst is so bright and also nearby, we think this is a once-in-a-century opportunity to address some of the most fundamental questions regarding these explosions, from the formation of black holes to tests of dark matter models. Newborn black holes discharge powerful jets of particles that can travel at near-light speeds, emitting radiation in the form of X-rays and gamma rays. The black hole's destruction finally reached our part of the universe, after billions of years of traveling across space. An event like this can reveal more information about star collapse, how matter interacts near the speed of light, and what conditions may exist in distant galaxies. According to astronomers, such a bright gamma-ray burst may not appear again for decades." Jillian Rastinajad, a doctoral student at Northwestern University in Illinois who led a second team using Gemini South, said, "In our research group, we've been referring to this burst as the BOAT, or brightest of all time, because when you look at the thousands of bursts gamma-ray telescopes have been detecting since the 1990s, this one stands apart." Is this explosion dangerous to our planet? Current estimates are that a gamma-ray burst will happen in our galaxy, or in a nearby galaxy, about once every many hundred years. However, it's pretty likely that the radiation would not have an impact on Earth. It has to happen pretty close to us for it to have an effect. It all depends on the beaming. Even objects very close to a gamma-ray burst can be unaffected if they're not in the beam path. However, if an object is in the path, the results can be devastating. There is evidence that suggests that a somewhat nearby GRB, or you can say gamma-ray burst, could have occurred about 450 million years ago, which might have led to a mass extinction. However, the evidence for this is still sketchy. What if we come in the way of the beam? This is what the gamma-ray sky looks like as seen by NASA's Fermi telescope. All the bright sources are emitting gamma rays at strengths greater than 1 GeV, that is giga-electron-volt. A nearby gamma-ray burst, beamed directly at Earth, is pretty unlikely. However, if one did occur, the amount of damage would depend on how close the burst is. Assuming one occurs in the Milky Way galaxy, but very far away from our solar system, things might not be too bad. If it happens relatively nearby, then it depends on how much of the beam Earth intersects. With the gamma rays beamed directly at Earth, the radiation would destroy a significant portion of our atmosphere, specifically the ozone layer. The photons streaming from the burst would cause chemical reactions leading to photochemical smog. This would further deplete our protection from cosmic rays. Then there are the lethal doses of radiation that surface life would experience. The end result would be mass extinctions of most species of life on our planet. Luckily, the statistical probability of such an event is low. Earth seems to be in a region of the galaxy where supermassive stars are rare, and binary compact object systems aren't dangerously close. Even if a GRB happened in our galaxy, the likelihood that it would be aimed right at us is pretty rare. So, while GRBs are some of the most powerful events in the universe, with the power to devastate life on any planets in its path, we are generally very safe. Astronomers observe GRBs with orbiting spacecraft, such as the Fermi mission. It tracks every gamma ray that is emitted from cosmic sources, both inside our galaxy and in distant reaches of space. It also serves as a sort of early warning of incoming bursts and measures their intensities and locations. We will continue bring you update from outer space. Till then, stay curious, keep exploring.